So what have we got next, David?
So next, let's introduce our speaker first. We're going to be joined by Thomas Richter from Container Solutions. Hey there, Thomas. How's it going? Hey, you're on mute, I'm afraid.
The classic. Okay. Hi, how are you?
Very well, thank you. So Thomas is going to be talking to us about cloud gaming today. And I'm not sure how much of the sessions you've seen yet, but if you might be warned or you may be prepared, but we're going to ask you a random question before we segue into your talk. And I think it's only fitting with you doing a talk on cloud gaming that we ask you, are there any games or games that you're playing, and which one are you most invested in with regards to time and hours?
What I'm playing at the moment, not that much less than in the past. But if I do, then Escape from Tarkov. It's a very intense game, very immersive.
Nice.
And yeah, but if I have the time and I want to play. But I love gaming in general.
Yeah, definitely. Gaming is fantastic. It's not something I feel that I get enough time to do, but definitely something I like to try and squeeze in a little bit of time at the weekends whenever possible. All right. Well, just given the time, I think we should quickly move into your talk. If you want to get your slides up, we can hand over and you can take it away.
Yes, I'm sure. There. All right. Does it work?
It is there.
All right.
Thanks.
Okay. Then hello, welcome everyone. Hope everyone is doing great today. So I'm Thomas Richter, Cloud Native Engineer at Container Solutions. We're also hiring, I have to say that. So yeah, go to our website if you're interested. But now to cloud gaming and managed Kubernetes versus Kubernetes on bare metal. That was our topic. First, the use case itself of the gaming use case, why we actually picked that. Then the comparisons of Kubernetes versus the managed cloud. Then performance analysis, cost analysis, and at the end, a little showcase where I show you actually games in the cloud on bare metal working. And yeah, so something to look forward to. Okay, first to the use case on why. So we've been working together with Equinix to write white papers about technical topics, and one of them was managed Kubernetes versus bare metal Kubernetes. And we wanted to pick something with unique hardware requirements where it's a challenging situation. It's not the norm, and so gaming was a bit of a fast pick there. Then we wanted to look at the performance considerations and also cost considerations. And well, how have we done that? We have set up it in both environments and compared it so to actually gather some data that we can work on. So yeah, about cloud gaming. What do I actually mean by that? So this is the very basic setup from a top-down perspective. We have a player with a very simple device in general, like a laptop, smartphone even, a good and stable internet connection, hopefully, and a server running somewhere with all the usual hardware we know, like CPU, RAM, and some SSDs or persistence layer. But the addition here is the GPU, which is quite a unique thing. GPUs and servers are usually in high performance computing, like data analysis, AI calculations, stuff like that, more common, but not so much where the GPU needs to put out a picture and then stream it back to the player as fast as possible and in good quality as well. So quite a unique challenge here. So that's the principal setup. First two Kubernetes differences of bare metal versus managed cloud. In this case, it's a more in general terms. For a comparison for the managed cloud, we later picked Google Kubernetes engine and the Google Cloud Platform. Reason being, they have a lot of support for gaming use cases already. They're working closely together with NVIDIA. They offer hardware recommendations and machines, and so that is why we picked Google. On bare metal, obviously everything running on Equinix Metal. So first things first, Kubernetes setup. A very big topic in terms of how difficult it can get on managed cloud. You, as a beginner, you don't need that much knowledge about it. You don't need knowledge about infrastructure tooling, like Terraform and stuff like that, or and all the scripts that go with it. You basically just can pick what hardware you want and put it in a Kubernetes configuration and run it, and you get a cluster fairly quickly and run a pod. On the bare metal side, you get an SSH connection, and there you go. It's your own. You need to make it your own, and therefore all the installations of all the Kubernetes components, you need to do it yourself, as well as the configuration. Obviously, you can make use of all the tools that are out there. Many options to do that, but first, you have to pick and choose one or do it yourself. Then on the managed service side, almost every cloud provider has quite the portfolio of managed services that a cluster can interact with, such as storage, load balancers, databases, stuff like that, that make it fairly simple. On the bare metal side, not so much there. We can have load balancers and some tools, but we don't have a managed database service, for example. So you need to add yourself what you need. That can be a good thing or a bad thing. And yeah, that's one of the differences as well. One example, for example, storage classes. You need to pick your own storage layer, what storage class you want to pick, like Ceph, for example, or cluster FS. You have full control over it, but you need to have additional work. On managed cloud, you have the K8s storage class. It takes care for you for most of things, but the configuration and possibilities are a bit limited here if you have some special use cases or run into an edge case. Then security. Well, on the managed cloud side, you have some default configurations and setups where the Kube API, the networks are secured by default. A lot of things are taken care of. Doesn't mean that you shouldn't never worry about it, but it's definitely more secured by default, as well as with the upgrades, upgrading and updating the images of the nodes for the operating systems and stuff like that. Whereas on bare metal, it's your own. You need to take care of yourself as well as with the security. Then it boils down to this. Basically, you have full control over Kubernetes. So basically everything that is in the GitHub repository of Kubernetes and all the forks, you can do whatever you want. On managed cloud, you have limited control. You can't configure etcd, stuff like that. For some providers, more or less, depending on the area, but you definitely don't get the full control like you do it on bare metal. And then tying in with the hardware choices, you have custom hardware choices to an extent on bare metal where you can configure it yourself and make it more fit for purpose. On managed cloud, you also can pick some stuff together, but it's only what the cloud provider offers for you. And for the hardware choices, I will come back to that later, where there can be a big advantage for the cloud computing, gaming computing use case. Okay, so let's go into benchmarking. So we ran some standardized tests, benchmarks that are widely accepted. So we put them into Kubernetes, into pods, and ran them specifically for these hardware components. So for CPU, we picked Sysbench, single and multi-threaded benchmarks. This is both on the Skylake platform on both providers. As you can see, Equinix Metal performs a bit better here. Reason likely being is that on Equinix Metal, you get the physical CPU available to you, whereas on GCP, you get virtual CPUs. So there is some abstraction going on, and that costs performance, and yeah, that can result in lesser performance. Then we also tested with 4 threads. It would be somewhere in between the single and multi-thread. So it scales quite linear. So then for the GPU benchmarks, we had GCP recommends us the Tesla T4 GPU for gaming. And on Equinix Metal, we get a Tesla V100. But here we could actually pick ourselves something. So we could talk to with Equinix and get something more end consumer graphics cards for the gaming use case from the GeForce lineup, for example. Those are less expensive and more performant in the gaming use case, whereas the Tesla lineup is more made for the high performance computing area. So it might be a bit overkill and not really fit for purpose. Here, the Tesla V100 is roughly equivalent of a 3080 from NVIDIA. That is one of their best cards at the moment, if you can buy them. They're really not available at the moment on the market, but it's roughly equal to that. On the T4, it's roughly equal to a 1080 in that performance benchmark. And the benchmark itself means 15,000 points. That's basically FPS rendered in 1 minute. So it renders as much FPS, frames per second, as it can. And as you can see, the V100 performs here much better. But later, for the cost considerations, it also plays a role where we actually pay less for the V100 compared to the T4. Then on the I/O benchmarks, we have SSD and HDD benchmarks side by side. SSDs compare a bit better on the read and write speeds on GCP. The HDDs, the Equinix Metal HDDs are a bit better, but quite similar, right in the expected range of that performance. However, we have one consideration here that our hardware configuration on Equinix Metal has also NVMe SSDs available, so the much faster SSDs that make use of the PCI lanes. Whereas on GCP, that is not possible for that configuration because it prevents us, if you want graphics cards, you don't get NVMEs. It kind of excludes each other, and therefore we couldn't even compare it if you want really NVMEs as well, because we want graphics cards, right? So they are not here. And this is how then the NVMEs would perform on Equinix Metal that are also being paid for, included with the server. Then network testing, that was based on the use case. So basically, we used our engineering team stretched out all over Europe to so basically be the player and test to our clusters with iPerf3. That measures ping and download rates. And the results are quite comparable for both providers. So 10, 15 milliseconds range for Equinix Metal for both providers, and very comparable download speeds. Both data centers were based in Amsterdam, and we were testing from Amsterdam and throughout Europe, and those are the average speeds from multiple tests. So quite good for both providers. However, later in the cost comparison, we see quite a big difference between the two. Then on the auto-scaling part, so we were interested in how much or how fast a cluster node could auto-scale. Both providers offer us a feature for that. So even on Equinix Metal, we could schedule a new node based on auto-scaling behavior. This is done by triggering talking to the CCM on Equinix Metal that can tell us to schedule a new node. And on GCP, that is basically a feature toggle already included in GKE. And here you can see that Equinix Metal takes quite a lot longer. These are seconds, almost twice as long. Reason being is actually because most of the time of the startup time is pulling the image down onto the machine. And GCP has some optimization here, probably with smaller images and very fast storage speeds. So with the time here on Equinix Metal, you could probably shave off a couple seconds here if you provide your own storage solution on the fast storage just next to it. And with a small image, you can reduce that time as well if you want. When the auto-scaling testing was done, we triggered the auto-scaling with a new pod that needs to be on a new node. And the test was finished until up until the point when the pod was scheduled on that new node. Okay, then let's go into the cost comparisons. So we had to make some assumptions here with the cost, some run numbers. The most important one for both is the 3-year runtime or commitment. So with a commitment, you get, if you commit for a certain time frame to any provider, you get quite the discounts because you reserve that hardware for you. So that's quite an important factor that plays into the costs. Then we assumed 1,000 GPUs. That would mean that 1,000 players would be able to play at the same time. GPUs are not really virtualizable at the moment with gaming like with CPUs. So one GPU session would equal one game session. And with 1,000 GPUs, we result in 250 nodes because on one node or one server, we can install 4 GPUs. That is true for both providers. And then we have some egress considerations. So if multiple players per day play a certain amount per hours per day with a certain resolution per day, video data takes a lot of data. And we are triggering egress costs for both providers. And those are 8,800 terabytes per month, quite a bit. And that would also then result in a certain cost charge. And then probably one of our most contentious numbers with operations costs. So SRE team, security team, and people like that need to take care of the service, install updates, install the cluster, and stuff like that. So the goal here is to show the difference between the. Oh, sorry, my laptop did something. The goal here is to show the difference between the discrepancy between the two, because Equinix or on bare metal, you would have a higher operational cost because you need to take care of all of these things, as I mentioned on the Kubernetes part, and with the upgrade, security, and stuff like that. So you just need more work power to take care of it. So we are assuming, and from our experience, the factor is somewhere around 1.6, 1.8, something like that. So we're assuming 10 people for GCP and 16 people for Equinix Metal. In reality, the number could be really different, but obviously there would be a higher load on the ops people on Equinix Metal. This is why we put 16 here, just to show the difference. I won't go into the single breakdowns of all the cost positions. That's in the white paper. But here, the total cost of ownership, we have 30 million. Also, this is after 3 years. We have 30 million for GCP, and Equinix Metal is around 18, 19 million. So it's quite a difference between the two. They actually start out at the same monthly cost, but then diverge quite a bit, where they end up at the end with a $11 to $12 million difference. And more interesting is the breakdown. So what does actually make up the cost between the two? And they're very different. So on Equinix Metal, we have the highest cost is the compute cost. So for 250 nodes, that would also include the storage, but that was almost half of the cost. Whereas on GCP, that's quite lower. But we see a really big chunk on GCP with the almost 60% for the network premium tier, compared to the 16% on the Equinix Metal tier for the networking. And as you saw before with the performance, at least for Europe for our testing, it was very comparable in terms of network performance. But on GCP, we have a much higher cost. that we can see in this breakdown here. Operations cost, of course, Equinix Metal is higher because of the 6 additional people, but also GPU cost is less because the rental over time, it's an operational cost is less over 3 years. So quite an interesting comparison between very different cost structures between the two. And for us, a very surprising result also with the network cost and difference with the high egress. That's due to the high egress amounts with the 8,100 terabytes per month. Okay, so quick conclusions from the performance and cost analysis. So in general, we have higher performance on Equinix Metal, and while being more cost effective. So it's both a win there. Then more flexible with a big asterisk. Equinix Metal can be more flexible in a way you have more choices for your hardware. You have more choices with what you want to integrate with. You can make the platform your own and build your own thing on top of it. And sorry, my headset just turned off. So you can make the platform your own and make and build everything on top of it, which is really powerful. As we saw, we have more flexibility with the hardware configurations. We have all the flexibility that goes into software, and that gives us a lot of power here. And but it's a really important thing to highlight that the operational side and the setup needs a lot of work and understanding about maintaining the servers, about maintaining the hardware and software, not the hardware, but the software components and interacting with the hardware is a bit different. But so the organization itself needs to be cut out for it. Yeah. So what's next? Also, we're going to release the white paper. With the white paper, it's going to be a GitHub repository, so you can run all the tests for yourself. It's set up in Terraform and scripts, so you can repeat the tests and verify them and see how it was built. Then we will, with next white papers, we will talk about storage solutions with high data and availability considerations. So that wasn't part of this white paper. We don't have really big databases going on. So that would be a topic for that with databases that are really big and scale really big. And another one, networking. So networking like Equinix Fabric, for example, setting up multi-cloud and all these considerations that goes into that. And well, maybe you got an idea what we should also take a look at. We still got a free slot, and feedback is always appreciated. So there are a lot of exciting things we can work with. All right, then these are my slides. Then I can show you a little demo of it working. So we've built a little test to get the graphics cards actually to work and interact with our with the end client. I just jumped ahead a little here. I wanted to jump into the game. So this is Parsec. Parsec is basically a remote tool that is optimized for gaming. It streams all the controller and inputs to the server and streams very fast the picture back to us. So it's a big, better RDP connection like in Windows. And so basically, I'm on my laptop that is not made for gaming at all. And so this is on our bare metal server running Minecraft. Let's go into bare metal world. As you can see, the loading time with the NVMe is quite good. And yeah, so I'm playing on a remote server and I'm streaming it to you, so there may be some artifacting, but it looks pretty all right on my screen. And if you get up the debug menu, the debug menu. Oh, well, okay. It runs around like 120 to 200 FPS on the server side, and with Parsec I can stream up to 120 FPS back to me. That would be rendered on my screen. Yeah. All right. That's it for me. Does anyone have any questions? A little demo.
I think I'm still waiting for. There we go. Thank you very much, Thomas. That was fantastic. Nice to see a working demo and a computer game, no less. We've got questions.
I'm really happy about it. Yes.
We've got questions, but a lot of them are not very technical, so I'll get to some of the technical ones later. So, Thomas, do you have the Minecraft data somewhere public so we can download and play the world you created with the Equinix Fortress?
This was a bare metal world, but actually we have this amazing. It's from the white paper, a little sneak peek. I'm still sharing my screen, right?
It's back now.
My colleague Charles made this amazing Equinix logo in Minecraft. He's on leave, so I couldn't ask him to get me this world. But it's an amazing build. So if you want to see Equinix logo in Minecraft, there you go.
Nice.
Maybe we can share that world.
All right, we've got a comment here saying that github.com/tohojo/flent is better than iPerf 2.3. So you might want to check that one out. Next question from Bucks578 saying, Thomas, what's the best city to live in Germany and why is it Mannheim?
It has everything you need around you. Yeah. Don't know who that was.
Rain asks, is there any interest in an Equinix Metal Container Solutions gaming tournament? I +1 this one. We did have a Container Solutions Software Circus, what was it? The Half-Life based thing. I can't remember what it's called anymore. That was good. Up next, what's the next question?
Yes, there is.
Oh, it's in Slack. Okay. Question was, what are those 6 additional positions? Are there other ways people can contribute to the team, or are they solely dedicated to working on Equinix Metal?
That's a really good question. Those are additional, basically additional workforce. So, for example, with the security aspect, you would need more security engineering. Doesn't mean that they are all 100% working on that very platform, but 250 nodes is actually quite a lot of nodes to take care of. But it's so more operations, SRE, more observation. Also with the observation tooling, you need to build it your own. So it's the additional workload related to the bare metal side.
Very good. All right, I think that's probably all we've got time for right now. So I'm going to thank you, Thomas, for this incredible work. As you said, the white paper's going out, and we're going to see that publicly soon. And there are more comparisons between public clouds and bare metal performance coming as well. Thomas, if you want to answer more questions from the community, you can go and join us at slack.equinixmetal.com and drop in there in the community channel. I'm sure there'll be lots of people that will have all sorts of questions to pepper you with. But for now, I'm going to say goodbye. So thank you, Thomas.
Thank you. Goodbye.
All right. So that brings us, David, sadly, to the end of the European leg of this 4-part Follow the Sun conference. Coming up next is US East, then we got US West, and then somewhat unsurprisingly, we have APAC. We've got a break coming up with the musical stylings of DJ Jennifer Langford, who by day works in PR and the Langford agency, does a lot of work with us. DJing, however, staying with the superhero theme, is her superpower. So we're going to see some of that. We've also got a hallway track at slack.equinix.metal.com, so you can go and catch up with all the other participants there while you're waiting for the next sessions. In a little over an hour, so let me be clear about that. So at 6 p.m. London, 7 p.m. Amsterdam, or 1 p.m. New York, we're going to start the second leg of this 4-part conference, where we're going to have people from LogDNA, Portworx, Cplane, Akamai, Google, Pure Storage, and more back with me in just over an hour. David, thank you so much for helping out.
It was a pleasure to be here. I've had a lot of fun, and all the sessions were great. Good job to all the speakers.
Agreed. And normally on this channel, you will see David talking about all sorts of things, along with Jeremy and various other guests. If you want to see those after this conference has happened, subscribe to the Twitch, and we'll see you at some time in the future. Otherwise, we'll see you in an hour. Thank you very much, and bye-bye.